Hi everyone, welcome to an introduction to data analytics in Python. In this set of videos, I will be introducing to you what is data analytics, Python tools, considerations about data and data sets, and how we're going to approach work in this course. So let's get to it. Let's first note the context of our lives today. Hyper digitized, where much of our activities are mediated by digital technologies. Our purchases are often online. If they're not online, if they are in person at physical store, they involve some digital method of payment, whether that is credit card or new methods of using applications such as Apple Pay. Often our political activities are mediated in the sense that they are put online on social media sites and farther communicated via these platforms. This information about activities, including text, images, and videos, are stored in databases, in data centers. They may be analyzed for marketing purposes, for political purposes. Much data is also captured and analyzed for industrial purposes, for business purpose, for engineering purposes. We certainly live in a hyper digital world and are even seeking to enter into this world, to completely submerge ourselves into it. And regardless of what you want to do and how you want to approach your connection with the digital world, it is hard, if not impossible, to escape the digital dimension of all of our lives. And oh, I went too far. Let's look at some of the information here about the accumulation of data in our world today. So, by some measures, in 2020, there were over 41 million WhatsApp messages shared on via this particular app. There were over 400,000 hours of video streamed by Netflix users. Now, this here is focused on how much data is generated every minute. So I'm actually not sure how you can generate hours of video in a minute. But anyways, move on to other parts of the data. We see an evolution here from 2021 to 2024 from 74 zettabytes of data consumed to 150 zettabytes of data consumed. And a zettabyte, I put a list here, is 1,000 exabytes, which is 1,000 petabytes, which is 1,000 terabytes, which is 1,000 gigabytes, which is 1,000 megabytes, and 1,000 kilobytes. So a zettabyte, I think it's 10 to the 21. It's 21 zeros. And of course, what does it mean to consume data? But the idea here is that the data accumulation and data use is growing. We have here another number, data growth in 2021, 1.1 trillion megabytes volume of data created every single day. It's just an enormous and really difficult to comprehend amount, but gives some indication of how much data there is. And also, we're talking about digital data. So this is data that can be potentially analyzed for all kinds of purposes, be they beneficial, nefarious, or somewhere in between. Here on the right side, if you want to take a look at, we have more information about social media in particular and how much data is going on and how much we're using data on social media. This is from 2017. Essentially, it's gigantic, it's enormous, and it's difficult to comprehend. And so we have found ways to analyze this data in what has been called data analytics. And data analytics here from Investopedia is defined as the science of analyzing raw data to make conclusions about that information. So, so in summary, just is the science of analyzing data. As some of you may be aware if you were in previous class with me or if you have uh, thought about this before, there is no such thing as raw data, and data is not meaningless. data is always already pre-constructed by humans to focus on certain dimensions, on certain areas of the world. It's already cooked in a certain way. And so this definition here is just focusing on analyzing data. So data analytics is in a way data analysis. The textbook says that data analytics is the science that analyzes crude data to extract useful knowledge or patterns from them. Crude data, maybe I can get more behind that, but to extract useful knowledge means, I think they mean useful information or patterns from them. This seems reasonable. Reasonable. I would not say it's the best definition, but it is coming from our textbook. So always pay attention. Just because um, the textbook, it doesn't mean that it's the ultimate truth. I have put it in these terms as the statistical and computational tools and methods for analyzing small and big data. So just the combination of statistics and computational analysis of small and big data. Big data meaning these new data acquisition that we're observing in the millions and millions of records, but also smaller, more traditional data, such as just a few hundred records and so on. Data analytical methods can help that as well. The concept is related to data mining, which is using algorithms to discover patterns in data. And this is the kind of inductive approach to knowledge creation, to information generation. So we don't know what's happening in the data. We don't really know which group is associated with which group, or even if the numbers are going up or down over time. And so we can use data mining to make these discoveries. And also data analytics is related to machine learning, which you may have heard about, which is in a sense building algorithms to automatically respond to input, to new data. And it is the science of training computational models so that they can respond to novel information or to make predictions about future occurrence. A related concept too is also data science, and sometimes data analytics is considered the same as data science. However, I think data science has a little bit more of more focused on machine learning, and machine learning, we use this abbreviation, this acronym ML. And here from the University of Michigan, it's a combination of hacking skills, math and statistics knowledge, and substantive expertise. And I think by substantive expertise, they mean domain knowledge. So whether it's medicine or marketing or other areas. Other data science perspectives, so skepticism, experimentation, simulation, and replication. So these skepticism is a kind of attitude to be curious and doubtful and trying to seek knowledge by testing and criticizing your own assumptions. But also these activities of experimentation, simulation, and replication as part of the activities of data science, and I would say data analytics. So we have a Venn diagram here with a combination of hacking skills. Hacking means kind of programming skills, math and statistic knowledge, substantive expertise. Danger zone over here. Actually, I think the danger zone is all over here. Everything is, there's nothing special about this part here that is danger. Any of this can be a danger zone, and of course any of these can be also useful and interesting zone as well. So here I have a chart from our world in data to show the time it takes for technology adoption. So this is the share of United States households using specific technologies. And I'm showing this graph for 2 or maybe 3 instances. So first is to say that just because we have a chart and we have data and it looks pretty and there's a lot of numbers and lines, it does not mean it's correct. Okay? Now, I'm not suggesting that it's incorrect. I just don't know, but it's coming from ourworldindata.org, so probably an organization. And so it could be accurate information. The data is households using specific technologies, and the y-axis is percentage, so percentage of households, and then on the x-axis it's year. These are time series graphs, line graphs, and each of the graph is a specific kind of technology. So some of these, I mean, in kind of large amounts is maybe relatively easy to capture. So you can trust the data because it's There are established channels where these data are accumulated, but that's something to be aware of. Secondly, I'm showing this chart to show something about on the computer here, on the computer side and on the smartphone usage, and I think the social media. So you can see also the uptick of the technology, the very steep slope here on how fast we have accumulated this technology. But it was a similar case to color TV and also color TV. It's interesting, color TV in the early 60s, also in television here. So for example, look at this, television. Television, the data only comes about 1990. So we're missing the data, or we don't really know what's going on here. So that's what I mean. Got to always be careful with the data. So was there no television before, or are you missing the data, or what's going on here? It looks like we have more data for color TV than just TV. So, but the idea is that we have different rates of adoption of technology, and we have computers and smartphone and social media usage have had internet here, tablet. They have had a very steep, very fast adoption. It seems like from a just eyeballing, eye observation here compared to some of the other ones. Some other ones are pretty steep as well. Microwave, look at this. This is almost like a straight line up. And so that's the second point. And the third point is that this kind of information, this kind of graphic, and this is actually a live dashboard that you can check by going to the link. This is the kind of work that we do with data analytics. So it's a very interesting example as well of what we can do with data analytics in the areas of visualizing data and creating dashboards that include computational methods, and you create apps that enable user interaction, user interface. And that's kind of what we do in data analytics. Another interesting one here from the National Conference on State Legislatures. This is a website, organization that keeps track of legislations. So we have a table here of data, and note that this is a table of legislations. So legislation is the unit of analysis. So each row in this table is a legislation. The word legislation doesn't appear anywhere, and maybe you can even think this is a bill, this is a table of states or something, but no, this is a table of legislation, and each row, each instance of the data is a legislation. And this legislation has various attributes like state and the bill number and the year and the status and the category and so on. And here we have a little application that enables us to filter the data. So if you click here on Medicaid, for example, it will select only the data where the category equals Medicaid. And you can use these other filters. And this is also an example of data analytics work, which combines both a little bit of statistical calculation, and a computer programming. Here we have a life cycle of a data analysis project, so some phases of activities in data analytics work from Northeastern University. And so the idea here is that there are various phases, various activities, and in this course we're going to be engaging in all of them, but some more than others, and also to a limited extent, because this can get fairly complex. And in this class we will touch on these phases, but not all the characteristics of all the phases. So phase one, it's understanding the business issue or whatever issue you're dealing with. It could be government issue or personal issue. Essentially identifying what the objectives are, what the gaps are, what the appropriate analysis methods are. And then step two, we need to understand the data, how to collect the data, the requirements for the data, and explore some basic characteristics of the data. Then we have step three, which is prepare the data. Often the data is not already totally prepared for the specific issue that you're addressing, even if you're already gathering the data for that specific issue. But in either way, often there's a lot of data preparation. So you may need to cleanse the data, that is, remove information that you don't need, or aggregate values that you do need to be aggregated. You may need to change format. You may need to sample just some of the data because it's too much or because of other statistical considerations. And then there is step 4, exploratory analysis and modeling. And here you need to develop a methodology for the analysis. Are you going to use a time series graphs? Do you need to do any hypothesis testing? Do you need to build a kind of logistic model? And so on. And once you do that, of course, and do that and run those models and execute those analysis, and then validate the results, evaluate the results via the different ways to evaluate. There's a whole set of processes as well to evaluate the results and determine the next steps. And then ultimately, you can feel comfortable to communicate your results either in a presentation or via visualization, and visualization too may be part of here, the exploratory analysis and modeling part. And there's the communication of the results, maybe determining best methods to present your insights, if you're going to publish, considerations about publishing, and so on. And of course, this is not in a circular way, but often we have circular processes. So after you explore, analyze, and model and validate, so for example, after you go from 4 to 5, you may need to go back to 3 again because some things were not right, or because the data was not enough or something, and then go back at it again. So there's always that circular iterative activity going on. So at the end, what we're going to be doing in this class is more about creating data calculations and data visualization. We're not going to build the most advanced artificial intelligence models to predict earnings of the stock market. We're really going to focus more on developing statistics, exploratory statistics, building some predictive models, do hypothesis testing, creating visualizations over time, over space, across different dimensions, and hopefully address interesting problems and be able to communicate our results in a convincing and satisfactory manner. That's a little bit about that. Next time we're going to be talking about Python tools.